Hello everyone and welcome to part 2 of our video series of polynomials for class 9th. In the previous video, we covered the basic concepts of polynomial such as degree, coefficient and constant terms, and how to perform addition, subtraction, multiplication on polynomials. In this video, we will continue our discussion and cover the remaining topics of this chapter. In this video, the first topic that we will cover is factorization of polynomials. And to learn about factorization of polynomials, we will start with our exercise 2.4. The first question is to determine which of the following polynomials has x plus 1 as a factor. Okay. So in this case, our first part is x cube plus x square plus x plus 1. Okay, now we have to determine if this polynomial has a factor of x plus 1. Okay, now we have already covered this type of question. So what we will do now, first we will put x plus 1 equal to 0 and we will find out the value of x. So x equal to minus 1. Now we will put this minus 1 in our polynomial and we will find out the value. So this will become minus 1 plus 1 minus 1 and plus 2. So our result is plus 1. So we will say that x plus 1 is not a factor of polynomial x cube x square plus x plus 1. Similarly, we can attempt rest of the three parts of this question. So now we will do the second question, and the second question is saying use the factor theorem to determine whether gx polynomial is a factor of px polynomial in each of the following cases. Okay, so here we have two polynomial. The first one is px, which is, we are doing first part. Px is 2x cube plus x square minus 2x and minus 1, and gx is x plus 1. So now we have to apply factor theorem to determine if this function is factor of this px function. So what is factor theorem? So factor theorem states that any polynomial px of degree more than equal to 1 it states that x minus a is a factor of polynomial px if pa equal to 0. Okay, what we have to do, we will just write this x minus a equal to 0. This will give x equal to a. So now we will put this a in our polynomial px. If our result value is 0, then we will say that x minus a is a factor of px. Okay, one more point in factor theorem. Factor theorem states that PA equal to 0 if x minus a is a factor of polynomial px. Okay, it is just converse of line of statement 1. In statement 1 we are saying x minus 1 is a factor of polynomial if pa equal to 0. Now we are saying that pa equal to 0 if x minus a is a factor of polynomial. Okay, you can note both of these points, then we will continue with our question. Now we can attempt first question, first part. So our polynomial px is 2x cube plus x square minus 2x minus 1, and gx is x plus 1. So what we have to do now, first we will put this x plus 1 equal to 0 and we will find out the value of x. The value of x here in this case is minus 1. We will put the value of x in our polynomial and then we will find out the value. This will become minus 2, this will become plus 1, this will become plus 2, and this is minus 1. So 1 is cancelled out by minus 1, minus 2 cancel out by plus 2. So our result is 0. If our polynomial is become 0, we can say that x plus 1 is a factor of polynomial. Okay, similarly you can attempt rest of the two parts. Now let's see question number 3. The question number 3 is find the value of k if x minus 1 is a factor of polynomial. Now the question is saying that x minus 1 is a factor of polynomial. You can refer to statement number 2 of factor theorem for this question. The question is saying x minus 1 is a factor of polynomial. So we know that if we put it equal to 0, the value of x will be 1. And if we put 1 here in place of x, the result will be 0. The statement number 2 of factor theorem. Okay, so in first part our polynomial is x square plus x plus k. Okay, now we will put 1 in place of x, 1 square plus 1 plus k, and it will be equal to 0 because x minus 1 is a factor of polynomial. So it will become 2 plus k equal to 0 and value of k is minus 2. So this is our answer of first part. Okay, now let's see one more question, second part. In second part our polynomial is 2x square plus kx plus root 2. Now we will put 1 in place of x, and then we will solve it. This will become 2 plus k plus root 2 equal to 0. So the value of k is minus 2 minus root 2. This is our answer of second part. Okay, similarly you can attempt rest of the two parts. Just we can attempt one more part number 3, where polynomial is kx square minus root 2x plus 1. We will put 1 in place of x, so it will become something like this, equal to 0. So k plus k minus root 2 plus 1 equal to 0. So value of k is root 2 minus 1. Okay, so the fourth part you can attempt by yourself. Okay, so now we will see few more application of factor theorem. So now we will do the question number 4, where we have to factorize the polynomial, and we will start with first part. So the first part is 12x square minus 7x plus 1. Now we have to factorize this equation, and we have already covered this question in our first part of the video, where we were finding the zeros of the polynomial by doing factorization method, and the method that we followed was splitting the middle term. Splitting the middle term. So we will do the same way. The first thing that we have to do in this question is to multiply the coefficient of x square with the constant number. So here the coefficient of x square is 12 and the constant number is 1, so we will multiply both of these numbers. The result will be 12. Then we will find out the factors of 12 in this way. Like the one factor is 12 into 1, another one is 2 into 6, another one is 3 into 4. Now we will check this. Now we will check all these three sets to find the value of 7 by adding or subtraction. So if we add 12 and 1, the result will be 13, and if we subtract them, the result will be 11. But we need 7, so we will ignore this set. Now just come to another set, add them and subtract them. But we need 7, so again we will ignore this set. Now check for 3 plus 4. Now we are getting 7. Okay, so what we will do, we will split the middle term using this factor 3 plus 4. We will write it as 3 plus 4x then plus 1. Now we will open the bracket, so it will become minus 3x minus 4x, then we have to add 1. Now we have to find the common terms in these pairs. So in first pair the common term is 3 and x. So if we took out 3x from this term, the remaining term will be 4x, and here the remaining term will be minus 1. Similarly, we have to find the common in these two terms. So there is nothing common in between them, so the only common number will be 1. So we will write minus 1, then 4x minus 1. Again we have to find the common term. Now we can write it as 3x minus 1 and 4x minus 1. So this is the final answer of this question. We just have to factorize the equation, we don't have to find out the zeros of this polynomial, we just have to factorize this. Okay, so let's see one more question. Which is the third part. Here the polynomial is 6x square plus 5x minus 6. So the first step is to multiply these two numbers, 6 and 6. So it will become 36. Now we will find out the factors. So the another factors are 3 into 12 and 2 multiply 18. Another factor is 4 multiply 9. Okay, now we will find out the 5 using these sets. So first try to add 6 plus 6 and 6 minus 6. Now the result is not 5, so we will ignore this set. We will try out with this set, 4 plus 9, and if we subtract these two, the result will be minus 5 that we needed. Okay, so we will use this set to factorize the 5x. So we can write it as 6x square plus 9 minus 4x minus 6. Further we can write it as 9x minus 4x minus 6. Now we have to find out the common terms. So it will become 3x, 2x plus 3. The common term between 4x and minus 6 is minus 2. So in bracket we have 2x plus 3. Again we have to find out the common term. So we can write it as 2x plus 3 and 3x minus 2. So this is our final answer. Now let's see question number 5, part 1. In this question the polynomial is x cube minus 2x square minus x plus 2. In exams generally you will see this question in 3 or 5 marks. So in this question what we have to do, we have to find out the factors of this constant number. So the factors are 1 and 2, and we will take plus and minus both. Okay, so first we will let x equal to 1. Okay, so just put x equal to 1 in polynomial. So the result is 0. Okay, and if the result is 0, we can say that x equal to 1 is a factor of this polynomial. Also we can say that x minus 1 is a factor of this polynomial. Okay, so here we have x minus 1 as a factor of this polynomial. Okay, now what we have to do, we have to divide our polynomial with x minus 1, and the way to divide is the long division method. Okay, so now we will do the long division, where our dividend is x cube minus 2x square minus x plus 2. We will divide this with x minus 1. I will not explain the full concept of this long division. If you want to see the all these steps, you can watch the part 1 of this video where I have explained the all these steps of long division method. To save our time, I will just divide the polynomial with x minus 1. So in quotient we will have x square, and here we will have x cube minus x square. We will change the sign. X cube will be cancelled, and minus 2x square plus x square, the result will be x square. Then we will copy the next term, and in quotient we will add minus x, and we will multiply this minus x with x plus x minus 1. So here we will have x square and plus x. Change the signs. X square will be cancelled, and minus x, this will become minus 2x. Just copy the another term, plus 2, minus 2, minus 2x, and plus 2. Change the sign. This will become negative. So we can cancel out both numbers and the remainder will be 0. Okay, now you can see another factor in quotient. So now what we have to do to find out the answer, we have to factorize this polynomial again, and the method that we will follow is splitting the middle term. Okay, so we can write it as x square minus 2x plus x minus 2. Then we will take the commons out, x minus 2 plus 1, x minus 2. So it will become x plus 1 and x minus 2. Okay, so now you can see we have three factors. First one is x minus 1, another one is x plus 1, and the third one is x minus 2. So we can write our final answer as x minus 1, x plus 1, x minus 2. So this is our final answer, and in similar way you can attempt the another three parts. And one more thing while doing this question, like here I have used x equal to 1 to find out the factor. Okay, so if x equal to 1 give you a non-zero term, so what you have to do, then you have to take x equal to minus 1. This will surely give you the 0, and if not, then you have to take x equal to 2 and then minus 2. But in exams question, generally you will get 0 by 1 or minus 1. Okay, so with this question we have completed our exercise 2.4. Now we will move ahead with exercise 2.5, and for that we have few algebraic identities that you have to learn before doing questions of exercise 2.5. Okay, so now we will see few of the identities that you have to learn. The first one is x plus y whole square is equal to x square plus y square plus 2xy. Second, x minus y square equal to x square plus y square minus 2xy. X square minus y square is x plus y and x minus y. Fourth one is x plus a, x plus b is equal to x square plus a plus bx plus ab. Then the next one is x plus y plus z whole square is equal to x square y square z square plus 2xy 2yz plus 2zx. Number 6 is x plus y whole cube is equal to x cube y cube 3xy multiply x plus y. You can also write it as x cube plus y cube plus 3x square y plus 3x y square. The seventh one is x minus y cube. This is equal to x cube minus y cube minus 3xy multiply x minus y. We can write it as x cube minus y cube minus 3x square y plus 3x y square. Then number 8 x cube y cube plus z cube minus 3xyz. This is equal to x plus y plus z multiply x square y square plus z square minus xy minus yz minus zx. Okay, so before doing 2.5 we have to learn, or we have to understand all these 8 identities, and this will help you throughout the year and in class 10th also. Like for example, if you see the question number 1 of exercise 2.5, question number 1 part 1, the question is x plus 4 multiply x plus 10. Okay, the basic way to solve this question is first multiply x with this bracket and then multiply 4 with this bracket and add all of the terms. Okay, but now we will use the identities to solve these kind of questions. Okay, if you see the question, you can find this identity similar to the question. In question we have x plus 4 and x plus 10, and in identity 4 we have x plus a and x plus b. Okay, in question, first you have to mention the identity that you are using. It will give you 1 mark in question. X square plus a plus b x plus ab. Okay, now if you compare your quotient with the formula, you can find out that a is equal to 4 and b is equal to 10. Now what you have to do, you just have to place the value of a and b in this solution. So x plus 4 and multiply x plus 10, this will become x square plus 4 plus 10 x plus 4 multiply 10. The answer will be x square plus 14x plus 40. Okay, so this is our solution. So that's why all of the 8 identities are so important while doing exercise 2.5, because in 2.5 we have 16 questions, and in all of those questions we have to use one of these identities. So that's it for part 2 of our polynomials video series for class 9th. We have covered the factorization of polynomials, remainder theorem and factor theorem, algebraic identities. I hope this video will helpful for you in understanding these concepts better. Don't forget to like, share and subscribe to our channel for more such videos. Thank you for watching.